The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to the illsoyadvisor.com webinar on solutions to effectively manage SCN and SDS, brought to you by the Illinois Soybean Checkoff Program. My name is Mark Ingridson. I'm with the ISA Communications team. I'll be moderating the webinar today. Just a couple of housekeeping items before we get started. If you included your CCA number when you registered for the webinar, and if you stay with us for the entire presentation, your number will automatically be submitted for 1 CEU credit in integrated pest management. If you're listening to this recording of the webinar later, you will need to go to certifiedcropadvisor.org, log into your account, and apply for a self-study credit. There will be an opportunity to ask questions during the webinar. Please submit your questions using the chat feature of the GoToWebinar interface. Please keep your questions brief and only to one point. That helps us direct to the right person and have those focused. So without further delay, I'd like to introduce Jason Bond and Nick Tinsley. Jason is a plant pathologist at Southern Illinois University. His research and teaching program focuses on disease management in row crops in the Midwest. Nick is a seed growth technical representative at Bayer CropScience, where he coordinates the evaluation, development, and demonstration of Bayer seed growth compounds for products in Illinois, Wisconsin, and Missouri. Both of these presenters are very knowledgeable, experienced, and their background in disease and insect management makes them well qualified to lead the discussion today about managing SCN, SDS. And with that, we'll turn it over to Jason Bond. Please take it away, Jason.
Thank you, Mark. I appreciate the opportunity to be able to talk today about two really important problems that farmers face each and every year. There is probably very few constraints that you deal with on a every single year kind of basis when you grow soybeans. Weeds is one of them, and these diseases and the pathogens that cause these two diseases are also one of those that it's just a yearly issue that we deal with. When we look at managing these organisms, I want to talk a little bit about the status of the diseases as it is now. What do we have with regards to our management options, and then also what's new. There's always a desire to know what's most recent information out on managing these diseases. The first thing I wanted to go through is just the distribution of cyst nematode. Everyone has seen this if you've been around managing this pest any number of years. You probably have seen this slide for the state of Illinois and really for most of the Midwest. Wherever you grow soybeans, this nematode has been found. One thing to keep in mind is that doesn't mean every single field and every one of those counties has the nematode, but all of our surveys at the University of Illinois, SIU, industry surveys, when you look at them over the last 10 to 15 years, they all tell us the same thing. About 80% of our fields are infested in the state of Illinois. So it's really more of a, you should assume that you have it, versus assume that you don't have it just because you can't see any things above ground that might point to something, a problem going on below ground. That is a very bad way to manage cyst nematode. In the South, under very stressful conditions, sometimes even in the Midwest, we will see above ground symptoms where you have really bad cyst nematode infestations. That's actually a good problem to have from the standpoint that it draws your attention to something's going on there, and then you can go and sample and you can determine what's causing that problem. But the majority of fields, we are dealing with an insidious pathogen that's robbing 30% of our yield, and we don't even see any difference above ground. That's very troubling. We have over 80% of the fields in the state of Illinois that are infested, and once those fields are infested, according to what we know about the pathogen right now, they'll always be infested. So it's something that we're going to deal with, and the grandchildren are going to deal with as well, unless there's some major changes with regards to how we manage or can control the pathogen. Recently, I did a presentation for some producers over in Indiana, and only about 45% of the fields are infested over there. So, I mean, you know, Illinois leads Indiana in so many areas, even in cyst nematode infestation. The resistant varieties are widely available for this disease. I mean, you pick up any brochure. It is hard to find varieties that are stated as being susceptible to cyst nematode. About 95% of those varieties do trace back to a single source of resistance, and that's a PI 88788. The remaining resistant varieties that you might be able to come across, that other 5%, would be kind of a hodgepodge of others, but most of those would be varieties with Peking resistance. And we'll talk a little bit more about that in just a second. As I said, this is an insidious disease. You can lose 30% of your yield and not see any visible symptoms. You see the picture over the top left-hand corner. This was a study that, a very elaborate genetic study that Greg Knoll did at the University of Illinois with the USDA, and had the precise treatments that are needed with regard to some isolines to prove that these nematodes could cause this level of loss, but yet nothing looks bad in the field. When you get to the point of seeing noticeable symptoms in the field, and this picture is from Iowa State Extension, if you see foliar symptoms being caused by the nematode below ground, you're in that 60 to 80% yield loss range. So it can be very, very devastating. And the reason why it is such a prevalent disease and why we'll always deal with it is primarily because of how this organism overwinters. This is the female after she has, well, actually not a female anymore. This is now the cyst. This used to be the female. And you can see the little eggs that are tightly packed inside of her body. So this nematode, as it's going through the female stages, she starts producing eggs. Some of the eggs she will produce outside of her body in this little gelatinous matrix. Those are immediately infective and will infect plants that current year. Then you have, it will also produce eggs and store them in her body, and those are typically, some of them are used in that current year, but many of these are for the following years. So anytime we go out and take a soil sample and we collect cyst, you will collect cyst from different years. So you have this huge mix of cyst in your field. When the eggs, this is what a single egg looks like, kind of like a little Tylenol capsule. When they hatch, this is what the little juvenile looks like. It's this is all under the microscope. The only stage that you would be able to see with your naked eye in your fields would be this the female stage right here. This is the stage that would be sticking out of the roots. Once they've turned brown, it so closely colors the what the soil looks like that it'd be very difficult to see. And then this is the once they penetrate the roots, these are the juveniles. This is as they start feeding. You can see their little feeding sites, and they'll continually to grow. So both male and females are prevalent in this population. The males will finally leave the roots and then come back and fertilize the females once they've been able to rupture through the surface of the root, and then fertilization takes place. So that's kind of a snapshot of how this organism reproduces. One thing to keep in mind, when we take soil samples, and you can send your soil samples to any number of labs, I recommend people send them to the disease clinic at the university, whatever state that they might be in. But there are a lot of good soil testing labs out in the industry. If you find one that's good, you need to stick with it, because you don't want to be bouncing around from year to year if you're going to be comparing the cyst nematode counts year over year. You know, you want to be able to be in the same lab, because each lab handles those soil samples a little bit different and have different extraction efficiencies with their samples. So that's the number one thing, not bounce around the labs. Number two, find you a lab that does not report the actual cyst count, but reports the egg counts that are in there, because when we go out and sample, we will find cysts that are full like this that might have 400 eggs, and then we'll find also depleted cysts that might only have half that amount or no eggs at all. So that can give you some misleading information depending on the inoculum potential of the pathogen in your soil, depending on how many eggs are in the cyst they counted. So it's a very simple process. It's not elaborate. All we do is we have a mechanism that we cause the eggs to be liberated from the cyst, and you count the eggs versus the cyst. So that's a very important thing as we go forward for you to make sure that you are using with your the people that are doing your soil samples. This is a highly variable pathogen with many HG types. In the past, we would call those races. You can still see that in company literature. Several surveys in Illinois indicate that over 70% of our field populations are now an HG type that reproduces on PI 88788. And seed companies are aware of this. However, the resistance from Peking and other sources is not deployed because there is a potential for yield drag. So if you were to go into one of these fields that had one of these more aggressive populations and you had really high numbers of cyst nematode in your soil, and I'm going to say high numbers, 1,000 eggs to maybe anything up to 10,000 eggs per 100 cc's of soil, for half a cup of soil, that's basically 100 cc's, just to give you a kind of a frame of reference. If you're in that type of density with this type, an HG type that reproduces on 88788, Peking would be a good source of resistance to use in that field. If you're in a field that has maybe an aggressive cyst population, but you've been doing a pretty good job and you've kept the populations really low in your field, they're still there, but they're at a more manageable number, maybe 500 eggs per 100 cc's of soil or less, then that's where we see those varieties with PI 8788 resistance. Even though this organism is still able to attack it, we still see them sometimes outperform Peking. So the companies have some of the genetic resources, but it's the accurate placement of these Peking varieties into the fields that need it most, which is most important. Broad acres across the entire region, PI 8788 is going to demolish Peking varieties in terms of performance. And so that's where we've run into some problems with getting more sources of resistance out there, is because of the stability of PI 8788 in association with high yield. So that's something moving forward that we'll need to be focused on. And this is just documents the shift in virulence that's occurred in Illinois. This was a survey back and done in 1991. So you can see at that time the Illinois populations were mostly this type 0. In the old days we called that race 3. But even then in 91 we see over 30% of the populations were type 2, and that designation indicates that it can reproduce on 88788. So shift forward to 2005, we see a flip-flop of that. The majority of the fields tested had a HG type of 2 or 1.2. So that tells us, and that's 2005. That's quite a number of years. We haven't done another survey since then. So this number has only gotten worse. We've not done anything to make this get better. We've continually done the same thing, which is deploy 88788 resistance into most of these fields. So this would just make this bar graph go higher, and probably this one go lower. So if you look around, we're not, it's not like the people in Illinois are the only people that are dealing with this problem. This is not just unique to this area. Everywhere we've deployed cyst resistance, we've seen this over the last 30 to 40 years. So if you look, 93% of the populations in Tennessee, 56% in Indiana, 88% in Illinois. This was a different survey than the one that Terry Niblack and I did that I referenced on the previous slide. And then this one here in Ontario, 27%, are all had populations of greater than 10% of reproduction on PI 8788, which would indicate it would be a type 2 population. So the current status, these Peking varieties will out-yield our current resistant varieties if the SCN pressure is medium to high in those fields. So that's important to remember. Peking varieties are often not as competitive with current resistant varieties if there's low SCN pressure. So the only way that we can get at do we have a low or high pressure is we have to be able to know what our populations are in our field. And for whatever reason, we've kind of moved away from the necessity in our minds of routine sampling of our fields, and I'll talk a little bit more about that in just a second. We had a recent conference down in Florida in December, and this was these are run about every 3 to 5 years, and it was all focused just on soybean cyst nematode. And I tried to summarize down really as it pertains to this call and what was learned in this conference. And there were a lot of things that really have intermediate benefits and then long-term. Most of this is long-term, but the people that work on this don't like for their research to always be considered to be 5 and 10 and 15 years out. Most of this is pretty. It's not going to help us this year or the next 4 or 5 years. Let me just put it that way. But there's been a lot of recent genetic discoveries and when I say genetic discoveries, both in the plant in terms of the host resistance, but also the genes for virulence in the pathogen that we didn't know until until just recently. So those are going to be able to be targeted and used going forward to help develop better resistant varieties. And then there's also been even additional discoveries about the pathogen that we did not know. So both of these things, they're really fantastic and they're great. We could spend all day talking about them, but that's not going to change how we manage the pathogen this year. Right now, what can be done and what was learned, they'd had several surveys that were talked about around that were done from around the country, and it was shocking how few people actually sample for cyst nematode. It's like in the numbers of like 10 and 15%. It's very disheartening. There was even fewer people that would sample for cyst nematode and then ever go back and compare prior sampling years. So you sample, but the only way that data is important if you're sampling for cyst nematode is if you sample and then you compare either back to the last time you sampled or to the time you'll sample when you sample in the future to see where those populations are going. If you're sampling just to see if you got cyst nematode, I can save you the money on doing that. There's a 88 or to 100% chance somewhere in that ballpark that you have it on your field based on all of our surveys. So sampling just to see if you got it and then never doing anything else with that information is not really a good use of that money. So there's also one of the things that was talked about is that the companies are doing a much better job getting varieties with different sources of resistance into those variety brochures. And I've worked with companies for over 15 years with this issue and testing some of the lines as a third party just before they go out. All of them are testing a lot of these Peking varieties with Peking resistance and other sources of resistance, but we don't ever see them make it to the brochure. And only now are we starting to see that. So they've been able to take away a lot of the yield drag that was associated with those other sources of resistance to make Peking resistance not only better than PI888 resistance in these infested fields, but also over broad acres where maybe the populations aren't as high. And the other thing that was talked about quite extensively is that we now have select seed treatments that do impact SCN. And that's important to protect not only our current resistance, but also future resistance that we deploy in our fields. So just as a summary, SCN problems in soybean are going to continue to get worse in the near term because most of our technologies and most of our habits are very difficult to change overnight. What is recommended is a frequent sampling plan, and we're not talking about every single year, but once every 4 years, use the same soil lab and make sure that soil lab is reporting the eggs per 100 cc's of soil or however many, whatever the volume they use is really inconsequential, but what is important is for them to be reporting eggs, not cysts. And then to be sampling that field again in 4 to 5 years down the road. And then our host resistance that we have, we need to be able to protect it with non-host rotation and also new strategies like these seed treatments. For so long, we just went at attacking cyst nematode with PI8788 resistance. And that provided many benefits for a long period of time, but that is now the usefulness of that resistance source is declining rapidly. So that's pretty much what I have for SCN. A very close component to managing cyst nematode is sudden death syndrome. These are two organisms that cause both SDS and also the soybean cyst nematode interact. They're in the same environment. And in fact, you can even isolate the pathogen that causes sudden death syndrome from the cyst of soybean cyst nematodes. So there's perceived to be some parasitism even of the nematode, not enough to actually be used to help us to manage the problem, but so there's some really interesting interrelationships between these two pathogens with one another and then also the host or the soybean plant that they attack. So just some some of the most classical symptoms of sudden death syndrome, the organism that attacks the plants obviously is not in the upper portion of the plant. If we're looking for it, we're going to be looking for it in the taproot. But what catches our attention, what makes this particular pathogen so different from a lot of the closer related Fusarium species, is the ability to produce these toxins that go up into the plant and then get expressed in the reproductive stages generally, and cause great degree of defoliation. And then even worse than that is when we start getting pod abortion, where we get these really massive reductions in yield. And we've been able to quantify this over many locations. Many universities have seen very similar things, is that at the full seed stage, for every 10-unit increase in disease, there's about a 7% reduction in yield. So this can really ramp up to where, especially when you're left with little sticks out in the field, the losses can be just devastating. I always get the question about, how bad was SDS in 2016? And it's really bad for the farmer that actually has it on his field, obviously. But when you look across the region, over the last few years, we really have seen a moderation in terms of the widespread devastation. It's still very severe, but it's localized in these pockets around the state. And it's really confounding to plant pathologists because we've had early to normal planting dates in many areas in 2016. The soils were cool with plenty of moisture, and boy, did we have plenty of rainfall. Those are all the things that we try to do to create disease in our little disease nurseries when we're trying to evaluate varieties and things of that nature, and this happened over a broad area. So we're still posed with this question, what's happened with this disease to where, if you compare back to 2004, if you drove around the state of Illinois around the first and second week of August, almost every field was showing symptoms of SDS. So there's a couple of things that have been going on with this disease, and one of them is host resistance. We are deploying more resistance into our fields today. Even people that are not specifically looking for it, because the companies are getting it in larger number in their brochures, people are deploying it sometimes and they don't even realize that they've chosen a pretty good SDS resistant variety. The reason why it took so many years for us to kind of get to this level of So sometimes, through no fault of their own, it's just very difficult to get good SDS data. But one of the things that we have seen about this pathogen and this disease is so far our resistance is stable, meaning that the resistance that's been developed and deployed in one field, we see that hold up across other fields, other states, wherever, if they're going into another area that's where that maturity group is adapted for use, we do not see the resistance failing. And we do see that with some diseases, but we don't see that with this particular disease. And that's, I pray that that never happens, because when you get into the situation like we have with Cyst nematode, we have all these differing degrees of virulence out in the field. We're not really seeing that yet with this pathogen, which is a good thing. And as I said, there's resistance is available. I mean, you can go into any variety trial and see differences in varieties. And sometimes you'll hear a description of the resistance as being partial resistance, and that is a true and accurate description of that type of resistance. But in dealing with producers and people in industry, sometimes the word partial doesn't sound good. You know, in America, we want everything to be full, but when you look on this particular variety, what this is describing is this resistance. These plants are still attacked by the pathogen. The toxin is still being expressed into the plants. This would be a two-row plot on the left. So these plants the toxin is being expressed, but the plants have resistance to that toxin. So there's only a few plants. It's not completely immune. We're not talking about immunity, but we are talking about a great level of reduction of SDS. That is a very good variety, and I would be willing to recommend that in any field in the state of Illinois. The variety here on the right, this is our susceptible check. And it is, you can tell, this is how you can determine if you have a good testing location to see, is there enough pressure to be able to separate out varieties. So how do we get this information that we can relate it to producers? Each year, the Illinois Checkoff and the United Soybean Checkoff fund a commercial variety trial, and you can see the locations that we have here in the state of Illinois. And then also some of those early maturity groups, like the Group 2s and Group 1s and even the zeros in some cases, are planted here in Iowa. And then so we kind of split some of the labor and resources, and we develop this variety report each year. And this just gives you a summary of what we found in 2016. Now, one thing I have to tell you is we only tested, and these I'm only showing the data from the Group 2s, 3s, 4, and 5. Of those that were tested, we had a total of 486 varieties that are just within these 4 maturity groups. And these are varieties that the companies chose to send in. So this may not be completely indicative of you just went out and randomly grabbed 480 varieties and planted them in your field. The people that sent these in some cases, they're looking for how good are our varieties. In some cases, they send them in because they know they're good and they want to see them score well in that test. So, but in any event, it does give us an indication of maybe some of the resistance that's out in the marketplace. This first category here, this is the number of varieties with a relative DX of less than 40. We've always used this as a pretty good marker for a variety that's got a pretty good level of resistance. We would be comfortable recommending varieties with this. They're still going to get disease, and you're going to still have yield losses. But for a long period of time, this was about as good as we could do in terms of deploying resistance. This would indicate 40% of the would have either 40% or less of the disease that you would see in those susceptible checks that I was telling you about. So each one of these maturity groups obviously has to have a separate susceptible and resistant checks. But we have a large percentage of the varieties that we tested that would have fallen in this less than 40% of the disease susceptible checks. So that's a really good thing. But what's even better than that is when you have varieties that have 10% of the disease or less than compared to your susceptible checks. Look at this, the number 97, 135, 35, and 10. So their companies have done a very good job of not only getting rid of the ultra susceptibles that were once in the marketplace, they've done a better job of keeping some of these things from slipping through the cracks that may be susceptible, and they've really done a better job of putting at the forefront some of their breeding techniques and for deployment of SDS resistant varieties. So that's one thing that we're seeing that is very encouraging. But one thing to keep in mind is this changes over time. So what we saw last year, which was so great in terms of the performance of the varieties, is not a predictor of what will happen this year or even in 2018. And we have data to support that. If you look, this is in 2005. This was our trial that we had in Valmeyer. This would have been just for the early 4 maturity group. You can see the susceptible check for our DX, which was 50. So this is just an outstanding level of disease. And then you can see the frequency of the varieties and these relative DX scores. So here's 1 to 10, 11 to 20, 21 to 30, and then 31 to 40. So this is that 40 DX I was telling you about earlier. We want all the varieties to be here and here. And if I was doing it, if I was planting on my field, I'd want this. But in some years, when you have maybe more moderate disease to no disease, these would be okay. They wouldn't be risky to plant them. So we see that in 2005. In 2007, some varieties probably were the same ones we tested that we had in 2005, but we definitely had a different influx of varieties. Again, this was at Valmeyer, just in this one maturity group. Here's our susceptible check. So we had a high level of disease again that year. We can see our varieties are starting to go in the towards the middle of this graph. We're getting over here closer to being pretty susceptible. Then 2009, still very similar level of disease, same maturity group, but we're getting into the wrong side of the graph. In 2011, still a high level of disease, but look how good the varieties performed in 2011. And then 2014, they went back towards the middle. And then the data I just showed you, most of them would be over here. So this changes You know, and there's big germplasm events that occur in the industry, whether it be the bringing in a Roundup Ready 2. Now we see this with the Extend. There's things that happen when that can explain some of this, and then some of it too can just be explained by the companies were going through periods of time where they were testing in environments that just didn't have good levels of SDS. That's pretty much all that I wanted to cover today. I wanted to leave some time for to Nick to talk about some of the things that they do for SCN and SDS, and then I'll be available for questions at the end of the webinar.
Okay, so thanks, Jason, for that great review of SCN and SDS and some of the changes that we're kind of experiencing now. I always learn something new whenever I get to listen to you give a presentation. I'd like to thank the Illinois Soybean Association for inviting me to come and talk about Alivo, which is a seed treatment that is relatively new from Bayer. And I want to kind of go over some details about this product in particular, as well as what we've seen in the field from a performance standpoint, and talk about some of the specifics as they relate to rate and some other things that go on with Alivo. So I guess without further ado, so what is Alivo? So Alivo is, the active ingredient is fluopyram, and this is an SDHI fungicide, is how it would be classified from a chemical standpoint. It has really two primary targets, one of those being sudden death syndrome, or Fusarium virulence that Jason mentioned. The second would be nematodes that are affecting soybean plants in the seed zone. And probably the most important one that we'll talk about would be soybean cyst nematode, at least in Illinois. Seems to be a driver pest. So with these two diseases, where the action is really occurring is down in the soil, despite the fact that, you know, with SDS we're seeing those above ground symptoms late during the summer. And so by targeting these two pathogens in the soil, a seed treatment really makes perfect sense, and that's kind of how Alivo is effective. So when we look at this graph here, obviously when we're looking at SDS, we're really trying to prevent these foliar symptoms, but by doing that, we're also controlling the root rot phase that goes on with SDS. So this is a root rot that goes on beneath the soil as these plants are infected by Fusarium virulence. In addition to that, in the soil, in that seed zone of that where that root is growing, we're also having protection against nematodes as well. So just so that we're clear on this, Alivo is not a replacement for a standard base fungicide system, something that might be effective against things like Phytophthora and Pythium or other Rhizoctonia, other diseases that would cause seedling blights. Alivo is really effective on these two pathogens. Okay. So this is a micrograph where you can, well, what we've done is try to be able to use green dye to visualize where on the root tip, in this particular case, you can see growth of Fusarium virulence. I think this is a really excellent slide for demonstrating, you know, how Alivo is having its effect. So if you look at these two micrographs, the one on the left would be the control, or the root that has been considered the control. So there's no Alivo on that root tip on the left, and you can see that there is a lot of Fusarium virulence kind of reproducing and colonizing that root tip. If you look on the right, where we've got a root that has been treated with Alivo at this 0.15 milligrams active per seed, in this case, you can see that the amount of fungal tissue that is growing, reproducing, and colonizing on that root tip is substantially reduced. And so this is what's going on beneath the soil as it relates to Fusarium virulence. And what that translates to is really some pretty spectacular ability for Alivo to help reduce the amount of SDS that we're seeing visually above ground later on in the growing season. And so this is a photograph that was taken sometime during early August or late July 2016. This field would be located in Peoria County. I had the fortunate experience to visit this field a few times. We were lucky that this grower and the retailer that he was working with put in what we call a strip trial. And so in this type of situation, what we've got is a split planter, where half of the planter has soybean seed that is treated with Olivo at the SDS rate. And I'll talk about what that rate means here later on. But what we see is a split planter situation where we've got a fair amount, we've got half the planter treated with Olivo, half the planter is the same variety, same base seed treatment, but just without Olivo. And you can see that there is a huge difference in the amount of foliar symptoms that are going on in those two areas of the field. One of the things that I did while I was visiting this field, and this is the reason I show this example is because it's indicative of a situation where Olivo is used in a situation where SDS can be quite significant. And so one of the things that I like to do when I visit fields like this is to dig up some plants and kind of scout these plants and see what they kind of look like. And so clearly above ground, what you can see, the plants treated on the left had Olivo, and the plants treated on the right were from the area of the field without Olivo. And so you can see that with Olivo, there's a significant reduction in the amount of SDS symptoms occurring in the foliage. In addition to that, if you look at the root system of these plants, you can see that those roots are more full and healthier looking generally than the roots on the right without Olivo. Those roots are experiencing a significant amount of root rot that's going on caused by that Fusarium virginiforme. And clearly there's been some pod abortion as well that's gone on. The difference in this field happened to be 19.5 bushels between these two areas. That's an extreme example. So SDS was very heavy in this field. That's not what we typically see on average, but it does represent a realistic example of what can happen with Olivo. So we've done a fair amount of testing with this, and Jason has been a big part of this over the years, with a number of university scientists and private cooperators trying to basically get at what is the average response with Olivo. And so I wanted to show this graph. This would be all of the data that we've got with Olivo from 2011 to 2016, which is since we've been testing it. And what I'm showing here is the yield benefit of soybeans that have been treated with Olivo compared to the same variety, same base treatment, only without Olivo. So each one of these bars would represent a trial similar to the one that I just showed the pictures from. And so what we see with this, 337 individual observations or trials, we see on average about a 4.7 bushel benefit associated with using Olivo, with an 84% positive response rate. Those are pretty good. That's a pretty good indication of the ability of Olivo to bring value to the table for SDS and SCN. I should mention that these trials are a mix of both sudden death syndrome as well as soybean cyst nematode, and there are varying levels of disease pressure in each of these trial situations. Another thing that we often kind of look at is what is the likelihood of getting above 2 bushels per acre as a benefit. We have close to 70% response rate for 2 bushels. And so that represents another metric of, I guess, how frequently Olivo can provide value to growers who choose to use it. Now, I realize that we're talking to predominantly an Illinois audience, and so I wanted to present some data that is both geographically very, very relevant. These trials are all from Illinois, and also very timely. And so these are data that from the same types of trials that I just showed you, only these were all conducted by retailers. So retailer demo trials will be run in a similar type way, split planter or split field situations. And again, what I'm looking at here is the yield benefit associated with using Olivo compared to the untreated base. same variety. So all our comparisons are going to be valid comparisons. So last year we had 67 of these out throughout Illinois. On average, what we saw was 3.3 bushels per acre from the benefit of using Olivo, with a 77% positive response rate. This data could probably be broken down a little bit further to kind of show what we saw in southern Illinois compared to northern Illinois. And if you were to do that, what I would think that you would probably see is that the benefit was maybe closer to 2 bushels in southern Illinois and maybe closer to 4 or 5 bushels in northern Illinois. And that's just the nature of how that disease really progressed last year. It was much heavier, north and west of Bloomington than it was, south of 72. So. Okay, so I get a couple questions about Olivo that I wanted to kind of address. So one of those would be, how is the benefit of Olivo when you have increasing levels of disease? And so one of the ways that we can measure how severe the disease is, like Jason mentioned, is to look at the disease index. And so this would go from 0 to 100. And what you're accounting for here is the severity of the disease and how many plants are exhibiting symptoms. And so again, we're looking at the yield benefit, and each of these bars would be an average of a number of trials to kind of fit in these different categories. So you can see that when the disease is really light, so let's say 0 or 1 to 10, the yield benefit associated with Olivo is significant, but not, extremely large. We're talking 2 to 3 bushels. When you start to get the disease really becoming prevalent, up here at 40 to 70 and greater, is where you start to see those yield benefits that can be quite substantial. Okay, 7, 10, 11 bushels, something like that. So as the disease gets more severe, the benefit associated with Olivo, really solidifies. Another question I get is, if I'm using a resistant variety, do I need to use Olivo? And I think we've done a number of trials that really hit home this point that not only susceptible varieties, but also SDS-resistant varieties can have a significant benefit from using Olivo as well. So if you look at this photograph, what we've got are an SDS-tolerant or resistant variety here on the left, and an SDS-susceptible variety on the right. And in each case, we've got a base seed treatment and the base seed treatment plus Olivo. And so you can see that when you go from the base seed treatment for the susceptible variety, and you use a resistant variety without Olivo, you get a significant improvement in yield. And in fact, if you use Olivo on a susceptible variety, you kind of make that variety look a little bit more like a resistant one. But when you start to add Olivo to a resistant variety, you can basically maximize the amount of yield potential that you're protecting. And we see that benefit, across different levels of resistance. So what are we doing for nematodes? I'm going to try and kind of get through this in the next couple of slides relatively quickly so that we have time for questions. So we've done some experiments last year where we were looking at exactly what effect we are having on nematodes. And this are specific to soybean cyst nematode. These were done by a professor at the University of Nebraska-Lincoln. And so these bars would represent the percent reduction of these various life characteristics of soybean cyst nematode. So using Olivo, we can reduce hatching by about 96%. We can reduce motility or movement by about 82%. And remember, it's important for these nematodes to move to be able to find and establish a feeding site on the plant. In order to do that, they're going to have to be able to penetrate the root, and we have a reduction of about 50% with that. And also a reduction in reproduction. So in order, obviously, to cause problems, they're going to need to sustain a population. And reducing their ability to reproduce by as much as half represents a pretty significant amount. Okay, so we're kind of approaching the end here. I wanted to quickly mention the rates that are associated with Olivo. Okay, and I think it's probably easiest to think about these two rates as one being the nematode-only rate and one being the SDS plus nematode rate. Okay, so when we think about these, if you look over here, we've got the nematode rate being 0.075 milligrams active per seed. So that is not going to give you protection against sudden death syndrome, but it will give you protection against soybean cyst nematode and other nematodes that are affecting soybean roots. with that, we expect based on our trials, a yield benefit somewhere in the neighborhood of 1 to 4 bushels per acre. And that's going to depend on the amount of pressure and other environmental conditions that exacerbate yield loss. When using the SDS rate, which would essentially be double the nematode rate, you're not only going to get protection against nematodes, but you're going to now pick up protection against sudden death syndrome. And so that's when we're starting to see these yield benefits of anywhere between 2 and 10 bushels to the acre. That's when this Olivo SDS rate is being used. Okay, I did quickly want to mention before I wrap up, for those of you who may have not had any experience with Olivo, something called the halo effect. So this is a small amount of phytotoxicity that goes on with soybean plants that have been treated with Olivo. So this essentially occurs predominantly on the cotyledons. It really doesn't extend up into the plant. But what we see here is kind of a chlorosis or necrosis occurring on the edges of the cotyledons. You can see it in these pictures down here. Sometimes if conditions are worse for soybean emergence, what you'll see is that those shapes on the chlorosis and necrosis may be a little more irregular. Once you start to see the cotyledons emerging out of the ground, their job is over. They're essentially serving as a food source to help those soybean plants emerge to a healthy start. We don't see any negative effect on stand, emergence, or yield in the absence of pests with this halo effect. It's simply a photosensitive reaction that goes on that the plants quickly outgrow, and then in the presence of the pathogens, obviously seed treated with Olivo is going to have a significant benefit. So I did want to mention this, and there's a lot of information available on this out there, kind of in the on the Twitter sphere and other social media, as well as our website. So that's all I have, and so I think we'll probably open it up for questions and things like that now.
Yes, thank you, Jason and Nick. We do have a few questions that have come in. If anyone has additional questions, again, there is a chat function in the GoToWebinar utility, so feel free to ask away. A couple of questions here. This one's probably directed at Jason. When is the best time to sample for SCN?
That's a great question. Typically, the most convenient is after harvest, and it also gives you a good read on if you're sampling a soybean field that just came out of soybean. That would give you a good read on how much reproduction occurred that year. It'd give you a good indication on the inoculum potential in that field. Now, how you interpret that information is very important, because if you were to try to grow soybeans on soybeans, that would be pretty important to know coming out of that that year what your population was in that field. If you're going to go into the corn rotation, keep in mind that you're probably going to cut that population in half with a single year of rotation with corn going back into your soybean. So that is in the literature. That is fairly predictable across the region, where the drop-off on returns on your investment in terms of non-host rotation. Let's say if you go 2 years of corn, that second year drop-off isn't nearly as great as that first year in your corn. If you were other times it might be good to sample in the spring. This would be a good spring to be able to sample fields that because it's been a lot drier than normal. It's a lot warmer now. We can get out and sample. So either of the two work are okay. There's not one really that's better than the other. Sometimes it's a little bit easier to get sampling done in the fall than it is the spring. I would say that if I was doing any fields that I was contemplating going soybean on soybean going into this year, and I have not sampled lately, I would definitely sample those fields, because if you had populations that are pretty high, you need to know, and I say pretty high, if there are over 1,500 per 100 cc eggs per 100 cc's of soil, I would think long and hard about perhaps that field needing to go into corn to bring the populations down. Can I get one of these varieties with a different source of resistance? or should I be considering some of these seed treatments to go along with the variety that maybe I've already chosen, and I'm going to plant in that field, and I'm not going to be dealing with corn. I want to go 2 years of soybean. So those are some of the things I would weigh, and depending on the year, I think we might have a lot more soybean after soybean, and those are fields that I would say need to be sampled this spring if they haven't been sampled within the last 4 or 5 years. So typically we recommend fall, but there are situations where spring works out well and may be really needed depending on the decisions that particular farmer is trying to make.
Great. Thanks, Jason. Another question here, I think probably directed to Jason, regarding the resistant varieties and the ability for SCN to persist in the environment, despite the fact that we have resistant varieties. And then a follow-up question to that, in terms of plant breeding or genetics, are there new things in the pipeline that are coming that are going to be able to help, aside from some of the other solutions that we talked about today, that you're aware of?
It's a great question. So when we deploy resistant varieties for cyst nematode, immediately the very first day that you would deploy something, let's say you went into a field and you deployed a Peking variety, they would be a small subset of the population that's in that field that would be able to reproduce on Peking. And when we measure the resistance level, we're basically, it's 10% or less compared to the 10% of the reproduction or less compared to the susceptible check. That's what we do for cyst. We've done it for a number of years. So when we deploy resistance for cyst nematode, it is not immunity. The roots still get attacked by the juveniles, really at the same rate as is susceptible in terms of the entry into the roots. Where the resistance is expressed is when the nematodes start trying to feed. And that's where there's a collapse in some cases of where they're trying to feed those cells. In some cases, they just can't get the nutrition they need, or the plant has any number of ways in which the resistance is expressed. It could reduce the number of eggs they produce because they're not getting enough nutrition. So when we deploy resistant varieties, it is not immunity. And then on top of that, even when we deploy a resistant variety that's working very well in the field, there is always a small subset of the population that's able to reproduce on that source of resistance. It's only 10% of the population. That's still a pretty good chunk of these nematodes when you think about how many trillions of them are in a single acre. So then you come back to next year, and if you use the same variety or the same type of resistance, you slowly are building or selecting those individuals that can reproduce on that type of resistance. So it's something very similar to what we see with the resistance to glyphosate, except it's happening below ground. All pathogens do this. If we throw a type of resistance or any type of one way to manage them at them, and we don't rely on additional things to help out that resistance. Yes, the second part of that question is, are there things in the pipeline? Yeah, there are some work that's being done at some of the universities and also with the companies, looking at ways in which these genes for resistance are being expressed, but to make them even more effective. Because sometimes we talk about a source of resistance, but by the time the breeding process has taken place and all of the improvements of that cultivar before it's released to a producer, sometimes all of the necessary genes aren't there anymore because of some of the breeding process. So they have better tools now. They also know what to be looking for to make sure that they're capturing all of the resistance that's needed out of these resistant sources. So so this has been a promise for many decades that to get new sources of resistance. But I think the combination of ensuring the level of resistance, knowing how that resistance is being expressed, and most importantly, combining that with some of these really modern, high-yielding varieties is probably what's going to be very helpful. But we're talking about, until there's like a massive change as it relates to when you're selecting your varieties in a brochure, that's not going to happen within the next 5 years. This is going to be a gradual process, and that's why while that process is happening, we need to be using all of the management tools that we have at our disposal.
Another great question from one of our ISA directors: is soybean cyst nematode present in South American soybean growing areas, and if so, how widely distributed is it there?
I know it is there, and I know it's widely distributed. I do not have the numbers across those different production regions, like in Brazil, but it is there. They are dealing with it. I would say that their complexity of nematode problems are way worse than ours. So everybody likes to hear, when somebody else is struggling with production issues more so than the U.S. Grower. But the things that they deal with, they deal with root knot nematode. That is much more localized in our production regions. It is a problem in parts of southern Illinois and southern Indiana, and then also into the mid and deep south. But it's much more localized on sandier soils. So that our nematode that we worry about in soybeans is cyst nematode. There in Brazil and South America, they deal with not only cyst nematode, but several species of root knot nematode, which adds to that complexity, and also a nematode called the root lesion nematode, which is Protolinkus, and there's multiple species there. And the companies have spent a lot of money trying to develop resistant varieties to this root lesion nematode, and it is a really primitive organism in the way in which it destroys the roots. And to my knowledge, they have not had much success. So we do have that nematode in this part of but for whatever reason, it's much more. We see more of a problem in our corn crop. Our environmental conditions typically don't allow root lesion nematode to just get over wide areas attacking our soybean crop. So yeah, they do have cyst nematode. It's not nearly at the top of their list of all of their production issues. It does rob a lot of yield, but they probably have just the total nematode problem with all of these other types of nematodes. It's probably of greater concern than just a single nematode.
Great. Another question maybe directed, Nick, here. Why are certain seed companies selling beans with a half rate of Elevo?
Yeah, so I can't really speak to the business strategy of any seed company for which I'm not a part, but I can say that I know companies are evaluating their footprints and trying to understand what rate is appropriate for what acres. I would probably argue that in Illinois the right rate would be that SDS plus SCN rate. It seems like most acres have those two pathogens, at least in a latent infection that could potentially cause problems in any given year. But yeah, I couldn't speculate as to why certain seed companies are choosing one rate over the other than an evaluation of the growers that they serve. So
it might be a better question for your seed dealer, right?
Right. Yeah.
Another question here, is there a direct and consistent correlation between SDS and corn-on-corn rotations?
You get mixed information depending on which study you're looking at. We typically like to, when we set up our SDS trials, we get more consistent SDS if we can follow at least a single year of corn. There's some data out there from Iowa State that shows that the organism that causes SDS does feed on corn that's left over in the field, that maybe some from harvest inefficiency. So it's possible that that's having some influence on why we see good consistent SDS after corn. We can get SDS if we do continuous soybean, but it tends to not be as predictable in terms of good data as following a corn crop. Going 2 and 3 years of corn does not eliminate SDS. We've seen SDS fields that have been hammered that have been in corn for 4 and 5 years. And then we've also seen fields that have been hammered with SDS that come out of CRP ground. So there's just a lot there of what we don't know about that pathogen. I think what's probably a bigger component of what's going on there when we go multiple years of corn, and then maybe even these cover crops and things of that nature, is we are making slight changes, I think, to the overall spectrum of the all these other microbes. Some of these are good microbes and some of these are other pathogens, but I think that when you go into that corn crop, we make some of these changes, and then perhaps things that are more aggressive than the SDS pathogen are more kept in check because they've gone through this year of corn, and you come back into your soybean crop, and this organism that causes SDS maybe doesn't have as much competition trying to get into the root. It is not an aggressive pathogen. When you think about all the things that the SDS pathogen deals with early in the year, it's attacking the root about the same time as the soybean cyst nematode, the Rhizoctonia that's in most of our fields, Pythium and Phytophthora, and also other Fusarium species. So it attacks in the seedling stage, but we don't see the problems of it until the reproductive stage of our plant. So other pathogens that attack the roots can cause competition with this SDS pathogen. So I think that's where you hear sometimes that this might have worked or that might have worked in terms of a rotation. It's not sometimes maybe what we're directly doing to this SDS pathogen, but the overall the community that's there. One other point I brushed over it, and when Nick was talking about some of the responses they see with Olivo with resistant varieties is, we even in my presentation, we are so focused on the above ground foliar symptoms, but as this pathogen attacks the roots early in the year, there's first a root rot phase of the disease that lingers throughout the whole year, and that's one way that you can see, even though something that may be a resistant variety and may not see a whole lot of difference in terms of the foliar symptoms, but you protected the plant in that root rot phase. And that's something that scientists across the whole country, we still don't know how much yield is lost, even in the root rot phase, even in those years when we don't see above ground symptoms of SDS, when it's been kind of hot and dry. The pathogen was there early, and it was attacking the roots and causing a root rot. That has some impact on plant health. And some years it can be very profound. Other years it may be very more moderate. But that's where some of these things with these seed treatments have actually opened up, even just to be able to ask other questions about this organism and how it impacts the plant.
Excellent, excellent, excellent. We are up at the 11 o'clock point. So with that concludes our webinar. Jason, Nick, thank you very much. We know this is a topic of great interest to a lot of growers, and the information you provided today is very, very beneficial. Thank you, everyone, for joining us again. This and all of our webinars are archived on the ISA checkoff-funded website, ilsoyadvisor.com.